Welcome back, everybody. Today we're going deep on recurrent neural networks.
Rnns?
Yeah, those AI things that are all about, like, sequences, right?
Exactly.
Keeping track of, like, what happened before. We've got this research paper. It's called Flashrnn, Optimizing Traditional RNNs on Modern Hardware.
It's really cool stuff.
It is. It is.
Yeah.
So basically, it's about making those classic RNNs,
Especially LSTMs.
yeah, the LSTMs, way faster,
Precision, yeah.
more efficient.
Yeah.
And it's like kind of leveling the playing field, right?
It is.
Against those transformers that everybody's talking about.
Right, exactly.
But especially for tasks, I think,
Yeah.
where remembering is really important.
Yeah, where context is key.
Yeah, yeah.
The authors make a really compelling case for why those traditional RNNs still have a lot to offer,
Okay.
especially when it comes to this idea of state tracking.
Okay, state tracking.
Yeah.
What is that?
Break that down for me in, like, AI world. So think of it like this.
Okay.
Imagine you're reading a book, right? You need to remember, like, the characters, the plot,
Mm-hmm.
all the relationships, all this stuff that happened earlier in the book.
To understand what's happening now.
Exactly. To understand what's happening now.
Got it.
That's state tracking.
So it's like memory.
It is. It's like having a good memory, but for AI.
Okay, so RNNs are like the memory masters
They really are.
of the AI world.
And that makes them super valuable for anything where understanding the past is important.
Like what? Give me an example.
Like analyzing time series data,
Okay.
stock market trends,
Got it.
even like figuring out the logic behind a series of events, you know?
Okay, so they're good at that.
Uh-huh.
If they're so good at this, why aren't they, like, more popular? Why don't we hear about them more?
Well, RNNs have had one major drawback, traditionally,
Okay.
and that's speed.
Speed, okay.
They process information step by step,
Okay.
kind of like following a recipe,
Line by line.
line by line. Transformers, on the other hand, they're designed for this parallel processing. So it's like having a whole team of chefs working on a meal all at the same time.
Oh, okay. I get it.
That makes them a lot faster.
So it's a trade-off.
It is.
RNNs are good at remembering, but slower.
Yeah.
Transformers are fast, but maybe not so good at, like, the remembering part.
You got it.
Okay.
That's where this FLASHRHRNN comes in.
Yeah.
It's designed to bridge this gap to make those traditional RNNs much faster
Okay. By doing what?
by optimizing them for how modern GPUs work.
Oh, so it's like giving them a speed upgrade.
Exactly. A speed upgrade.
How do they do that? I know the paper mentioned something about fused kernels
Yeah.
and headwise parallelization.
Right.
What is all that?
Think of it like this.
Okay.
You got your team of chefs again
Okay.
working in the kitchen.
Mm.
FLASHRNN is like giving them a super organized workspace, you know?
Okay.
And really clear instructions
Yeah.
so they can work on different parts of the recipe at the same time without, bumping into each other. That's what the fused kernels and headwise parallelization are all about.
So it's like streamlining everything.
Exactly.
Yeah.
Making things run smooth and efficient.
So FLAHRNN is all about, like, optimizing for the hardware.
Mm-hmm.
But how does that translate to results, like
Here.
in the real world?
Yeah. Did they actually see improvements?
Yeah.
Oh, absolutely.
Really?
Yeah. They found that FLAHRNN was up to 50 times faster than, like, a standard PyTorch implementation of an RNN.
50.
Yeah, 50 times. It's huge.
That's incredible.
Yeah.
But speed isn't everything, right?
Right.
What about accuracy? Did they have to sacrifice accuracy to get that speed?
That's a great question.
Yeah.
And to test this, they use this really clever benchmark called the parity task.
Parity task.
Yeah, it's basically a memory game for AI.
A memory game.
Yeah.
Okay, I'm intrigued.
So it's a simple task, but it requires remembering past information to make a prediction.
Okay.
And what they found was fascinating.
What?
RNNs powered by FLAHRNN, they totally crushed it.
Ooh.
Yeah, while those fancy transformers, they struggled.
Wow, so even with the speed boost, the RNNs were still better at tasks that require, like, a good memory.
Exactly.
Huh.
This shows that traditional RNNs, especially when they're optimized with techniques like FLASHRNN,
Uh-huh.
they can be incredibly powerful and efficient for specific tasks.
I see.
It's not just about raw speed,
Yeah.
It's about using the right tool for the job.
Okay.
And sometimes the right tool is an RNN with a good memory.
It's kind of making me rethink these RNNs now.
Yeah,
It seems like FLAHRNN is making some waves in the AI world.
it is.
It's challenging some assumptions.
Yeah, about which models are best for what.
I see, I see.
And the researchers didn't stop at just speed improvements.
Okay.
They also looked into how FLASHRNN leverages the memory hierarchy within a GPU.
The memory stuff.
Yes.
Okay, you had a really cool analogy for this, I
I
remember.
bet it didn't I?
Yeah.
So think of it like this. A GPU has these different levels of memory. You've got HBM, which is like a massive warehouse.
Okay.
You store tons of stuff there. It's big, but it's slow to access.
Okay.
Then you have SRAM, which is like a local shop,
Oh,
smaller, but much quicker to get what you need.
Uh-huh.
And then you have registers, which are like your backpack.
Got it. Okay.
Tiny, but super fast to access because they're right there with you.
So Flashrnn uses all of these.
Yes.
Okay. How?
Well, it utilizes this library called constraint.
Constraint. Okay.
It's like a super efficient logistics manager
Okay.
that figures out the best way to use all those different memory levels.
So it's putting the right data
Yeah,
in the right place at the right time.
exactly.
Okay.
Making sure everything flows smoothly.
So that's a big part of why it's so much faster.
It is. That clever memory management is key.
I see. I see.
Yeah,
So besides those speed gains on the parity task,
right.
did they test FLASHRNN on anything else?
They did. They tested it on language modeling tasks,
Language modeling. Okay.
which is like a common benchmark for evaluating these sequence models,
And how to do.
how to stack up against the transformers.
Yeah.
Well, it's interesting. While RNNs haven't quite surpassed transformers in language modeling,
Okay.
the benchmarks show that they're not as far behind as you might think,
Really?
especially when you factor in FLSHRNN's speed boost.
So it's closing the gap.
It's closing the gap.
That's pretty encouraging for RNNs.
There's definitely potential there.
Yeah.
And, the researchers even hinted at some findings related to numerical accuracy
Okay.
that suggest that FLASHRNN might have some subtle advantages
So for what?
over the standard PyTorch implementation of an LSTM.
Interesting.
Yeah, we might have to do a whole deep dive on that one.
We might.
But for now, maybe we can switch gears and talk more about those language modeling benchmarks.
Yeah. What kind of tasks were they looking at?
They looked at a variety of standard language modeling benchmarks.
Okay.
Things like PenTreeBank and Wikitext.
Okay. So
These involve tasks like predicting the next word in a sequence,
got it.
which is crucial for stuff like text generation,
Wow.
machine translation.
Okay. So they're testing how well these models can understand and generate human language.
Yeah, basically.
And what were the key takeaways from those language modeling benchmarks?
One interesting thing was that while the FLASHRNN RNNs didn't beat transformers in terms of overall accuracy,
Okay.
they were significantly faster.
So back to that speed advantage.
Speed, speed, speed. It's a theme.
Yeah.
And this speed difference could actually be a deciding factor, right? For practical applications where you need things to happen in real time.
Yeah. Yeah. If you need the results right now.
Milliseconds matter.
Yeah, exactly.
Did they get into why FLASHRNN seems to be so much faster for these language modeling tasks?
That's what I'm curious about.
They did.
Yeah.
And they attribute it to a few things,
Okay.
including that efficient memory management we talked about, the use of those fused kernels, and something called headwise parallelization.
Wait, didn't we already talk about that?
We did!
I thought that was just about speeding up the computations within a single RNN unit.
Right, but here's where it gets really cool.
Okay.
FLASHRN actually applies this idea of headwise parallelization to the entire RNN architecture.
Okay, now you've lost me.
How do you parallelize an architecture?
Yeah, how do you parallelize a whole thing?
Think of it like creating multiple smaller RNNs
Okay.
that all work in parallel.
Okay.
Each one focuses on a specific part of the input sequence.
So instead of doing it step by step,
You divide it up,
got it.
you divide and conquer.
Okay, so it's like divide and conquer, but for RNNs.
Yeah, pretty much.
This is getting complicated.
It is a little mind-bending,
Yeah.
but it's super effective for taking advantage of all that parallel processing power.
Yeah, the GPUs have.
Exactly.
Okay, so that's headwise parallelization,
It is.
but for the whole architecture.
For the whole thing.
Okay, I think I'm starting to get it.
And the paper goes into the math of it.
Oh, they really went deep on this.
It did.
We've been talking about all these technical details.
Right.
But I'm wondering, what does this actually mean? What's the real world impact of this?
Yeah, the implications.
Yeah.
The researchers think FLASHRNN could really revitalize interest in traditional RNNs.
Okay.
Especially for those tasks where remembering context is super important.
The state tracking.
Yes, state tracking is key.
Okay.
And they point out a few areas where they think LSHRNN could have a big impact.
I'd love to hear about that.
Okay, so one area is robotics.
Robotics, okay.
Imagine robots that can understand and respond to sequences of events,
In real time?
In real time, thanks to FLASHRNN.
Right.
They could navigate, really complex environments,
Right.
interact with humans more naturally,
Wow.
even do tasks that require understanding, like temporal context, what came before.
That's pretty amazing.
It's like giving robots a more human-like way of thinking about the world. Another area is scientific modeling.
Scientific modeling. That's
Think
good.
about using RNNs to analyze and predict things like weather patterns,
Okay.
protein folding,
Got it.
all those complex phenomena
Yeah.
with the speed boost from FLASHRNN. These models could process tons of data.
And maybe give us insights that we couldn't get before.
Exactly.
So it could accelerate scientific discovery.
It could.
Wow.
And there's one more area that I think is really exciting.
Okay.
Creative AI.
Oh, yeah.
Imagine using F8 RNN powered RNNs to generate music,
Okay.
art,
Uh-huh.
write stories.
Write stories. Wow.
With this enhanced ability to process and understand sequences,
Yeah.
these models could unlock all these new levels of creativity.
That's pretty mind-blowing.
It is.
But with all these benefits,
Yeah.
are there any limitations?
That's a good question.
Yeah.
And the researchers do acknowledge that there's still work to be done.
Okay.
One of the key challenges is scaling FLASHRNN up to bigger models and data sets.
Exactly. That's right.
Okay.
So LAHHRNN has shown great results, but in AI, there's always this push to go bigger.
Yeah.
So how to implement FLASHRNN on really massive models?
Okay.
The kind that are pushing the limits of AI. That's a big challenge.
So it's they've opened up this new way of thinking about RNNs,
Yeah.
but now we got to figure out,
How to take it further.
how to really push it.
Push it to the limit.
Okay.
And that's what's so exciting about this research.
I see.
It's not just about what they've shown us, but what it could lead to.
Yeah, the possibilities.
We've talked a lot about the technical stuff,
We have.
but I'm curious about the bigger picture.
Yeah, what does this mean for AI overall?
Well, I think it tells us not to dismiss the older ideas too quickly,
Okay.
especially when there's still room for improvement.
It's the classic RNNs,
They were just waiting for their comeback.
waiting for their moment,
Yeah.
and FLASHRN has given them that. By solving that speed problem,
Yeah.
now they can really compete with the transformers.
It feels like things are changing
Things are shifting.
in the world of AI.
It's an exciting time.
And the best part is
What's that?
the researchers made their code available online.
Open source.
Open source, yeah.
We love that.
It's so important
It is.
for making this tech accessible to everybody.
It really speeds up progress.
Absolutely.
So now anyone can try FLASHRN.
Researchers, developers, even just hobbyists.
Yeah.
It's amazing.
It's a great example of how collaboration can lead to innovation.
Who knows what people will come up with?
The possibilities are endless.
I can't wait to see what happens in robotics,
Mm-hmm.
scientific modeling,
Yeah.
creative AI.
All of it.
Well, this has been a fantastic deep dive.
It has.
We went deep on FLAHRNN,
We did.
from the technical details to the bigger picture.
The whole shebang.
Before we wrap up, any final thoughts for our listeners?
Just this. If you're at all interested in sequence modeling, whether you're a pro or just starting out,
Okay.
don't be afraid to try out FLASHRNN.
Yeah.
The resources are there. The community is growing.
Okay.
The possibilities are endless.
I love that.
Yeah.
To all our listeners, check out FLAHHRNN and see what you can do.
We might even feature you on a future episode.
You never know.
Yeah.
But until then, keep exploring, keep learning.
And keep diving deep.
That's right. See you all next time.